All good. So thanks for inviting me, Janice, to come along. So what I've tried to do is bring together some different little bits of work that we've done in Dryland Rivers over the years to sort of put together a story that leads into some of the issues that we saw in the Northern Murray-Darling Basin last year. And it's meant to be just sort of a bit of a high-level perspective on management in dryland rivers. So where are our dryland rivers? And I mean, I love this image of Australia, which is basically off the bomb and off Twitter. But if you can see my mouse, which you may be able to do on Zoom, dryland rivers, they're characterised by the rivers across the country that have highly variable hydrology, and that pretty much includes quite a bit. But we tend to be really focusing on those big rivers in the Lake Eyre Basin and the rivers in the Northern Murray-Darling Basin. But the rivers of the wet, dry tropics in the north, many of those rivers are actually pretty dry land as well in many ways. They're very variable hydrology, even though they're characterised by that sort of wet monsoonal. That's really variable for many of those rivers as well. So one of the key features in some of these big river systems is that they undergo this sort of dynamic fragmentation where they shift from short periods of high connection, so highly connected during flood events, complete to the point where you may have flood connected right across the floodplain, down to periods of extreme fragmentation where they're isolated water holes or just long reaches of river system that are disconnected from ana branches and other parts of the floodplain, and sections of the channel might be completely dry as well. One of the things that we've looked at, and I've looked at as well, is the kinds of animals that live in these systems that can cope with these really variable hydrology, from periods of big floods down to water holes being quite isolated. And the invertebrate fauna of all of those dryland rivers across the Lake Eyre Basin and the Northern Murray-Darling Basin, it's not particularly exciting if you're looking for dynamic fauna. It's not particularly species diverse. It's got a reasonable family diversity, but it does tend to be characterised by some pretty tolerant beasts, the things that can just hang out during many of these dry times. And so the traits that they display are sort of suggestive of that sort of resistance, resilience, tolerance. And we can characterise them into different sort of ways in which they survive that quite variable hydrology. There's the organisms that can move. They don't, when the system's fragmented, they don't need water to actually get around. So some of the beetles and the hemipterans, if we're talking about invertebrates, they can move between water holes and they're not stranded by that sort of fragmentation in space. There's a range of organisms that are what we might call desiccation tolerant stayers. They'll hang out whether it's dry or whether there's water in there. They've got desiccation resistance life stages, or they can actually just cope with dehydration. So some of the a lot of the zooplankton with their desiccation resistant eggs, but mussels and snails have some tendency to be able to cope with some drying in many of these northern basins, particular species of particularly the Velosunio mussels. So they're probably likely to survive short periods of drying of a waterhole. So they tend to occupy more of the landscape. And then there's some organisms that can really only just survive in those permanent refugial waterholes and permanent parts of the channels, and fish, crustaceans, and some of the invertebrates that won't survive the drying. So you end up with this community that's a mix between things that can move around rapidly in the landscape, things that just remain but can cope with the drying, and then there's the things that you really only get in the parts of the landscape that are really permanent. One of the other things that's quite characteristic of those river systems is this extreme ability to build up massive abundance after flood events. And this is data from way back in the old CRC for Freshwater Ecology Dryland River Refugium project that just shows the abundance of fish and macroinvertebrates after a connected flood event. So you can see down here on this green hydrograph, there was a big flood in the January of 2000. And even though the discharge dropped off, excuse me, the system is still quite connected. And there was a small event again in January. And so when that first sampling happened in April, all of this floodplain had dried down into the channel network and the waterholes were still quite full. But you can see the abundances in the open bars here of fish were massive. So this is catch per unit effort. So in all of the waterholes that were sampled, fish abundance was quite high. And in some of the waterholes, it was really off the scale, 49,500 fish catch per unit effort in this particular waterhole here. And even the macroinvertebrates in April were much more abundant than they were 6 months later when the system had dried right down. In September, the abundances had dropped off, and the same in the fish. So in these waterholes, you'd gone from 49,500 catch per unit effort down to about 1,000 just in that 6 month period. So a massive drop in biomass. So really responsive to flooding, but again, dropping down to just a resilient population that survives into the dry periods as well. From this same study, just to look at diversity through time, this is the macroinvertebrate data, we looked at spatial variation. So this is a multi-dimensional scaling plot, and each of these points just shows you how similar, the closer the points are in this plot, the more similar the community was. And these ones up the top here, the coloured ones, were all from April 2001 from 4 big areas of the Lake Eyre Basin. And so what we found, and then this yellow one, Windora site, was tracked through time over 3 years. And what we found in that part of the work was that the spatial variation after the big connection was less in terms of the community composition than the temporal variation at one site over 3 years. And this was actually over a drying period, a small connecting period, and then some more drying within that same site. So you get this big temporal variation in the community. And so one of the ways in which that community is likely to be working is that when things are connected, and this is a bit of a graphic, when they're connected, you've actually got quite a similar community across the landscape. As they dry down, each of these little boxes might be a different waterhole, they start to change. Now, the community, I guess, theory around that could be in any one of these waterholes, you might get dominated by particular kinds of fish, and that drives the invertebrate community in particular directions. And a lot of this is speculated or hypothesized, and we've never actually been able to track in these very isolated systems over long periods of time. The longer the systems are isolated, the more divergent the communities in each of these isolated water bodies become, until you get flooding again, where you actually end up with a bit of a merging of the community. And one of the big questions is, do they then go back the same, or do you actually get a change the next time you get a disconnection? Do you get different communities in the same waterholes just because you get different predators and other things that end up there? So what this is just sort of trying to summarize is you've got this enormous spatial and temporal variation of diversity and community responses across dryland rivers. They're really quite dynamic, even though the base fauna isn't that exciting. They're just dynamic places in terms of species changing through space and time. So these periods of flooding and drying are actually also, the signature is that you tend to get these clusters which are driven by the La Nina events that you get across that eastern part of Australia. And you'll get a series of floods that occur, and then you'll get these long periods of dry. And even in the Murray-Darling Basin, you tend to get, these are probably not the best hydrographs to show it, but you do tend to get series of pulses that come on the back of each other, and then you get these periods of dry as well. And one of the things that those sequences of floods do at a broader landscape scale, so if we zoom up away from just channels and waterholes and think about wetlands, at that broader landscape scale, we have these floodplain wetland complexes that fill up on each of these flooding events. And so this is the Lake Eyre Basin, and you can see these big floodplain areas all around the system. And we've got the same thing in the Murray-Darling Basin as well. Big floodplain wetlands that occur at the terminuses of quite a few of these river systems. The tributary river systems. And as those wetlands fill, after a period of extended dry, one of the things that was noticed in the Lake Eyre Basin, and you can read, I'm not going to read it out, but that's text that was from Jim Puckridge's PhD thesis. When he was sampling in the Lake Eyre Basin from 1987 through to 1991, he noticed that in a sequence of flood events, the water pushed its way through the Coonjee Lake system further and further on every flood event. As if the wetland filled up, the next flood that came through actually went further down the system and resulted in even bigger production. And so we end up with this sort of, I guess, perception that these floodplain wetlands are like big sponges, and they start, once they're wet, the next flow that comes through actually pushes further into the system and then fills up the next floodplain, wetland. So there's sort of like these big fill and spill wetlands that keep the land hydrated and allow the floods to penetrate through the system much further than would happen if the wetlands were dry. So the nature of La Nina events is you do get these sequences of floods, and this is probably how they're working in that big landscape scale, filling up these terminal wetlands, and then the next flow event comes through and pushes further down the system and fills up the next lot of wetlands and channels. And if you get a third flood and you're really lucky, that's when you start to boom to a really big flow event. So I just wanted to quickly reflect on what happens when you start to pull water out of systems and not let these floodplains act as big, or these wetland floodplains act as big sponges. You start to reduce the capacity of the water to penetrate down the system. And this is one of the things that last year when we were looking at the impacts of, or what might have actually caused some of the fish kills in the lower part of the Darling, is thinking about that water extraction and the fact that all of those terminal wetlands upstream no longer actually really fill to the same extent they would have done. And so the capacity of water to get down to Menindee is decreased over that sort of long flow regime sequence, because it's the last big wetland complex in the system. And so irrigation itself in systems in dryland rivers, irrigation acts in a way like a wetland itself. It's just that the water's removed from the channel to flood the wetland, which is now the off-stream storages. And what that tends to do is it means the natural wetlands aren't filling up. The water's actually going onto the floodplain in a much more a sink way. It doesn't allow water to then travel through the system. And so they don't tend to contribute to the downstream flows, which causes a drying of the system basically from the bottom up. And all of that on top of increasing temperatures in places like the Northern Murray-Darling Basin, where it's going to take more and more water to just to fill up some of these channels once they dry, because the water moisture of the channel just decreases so massively under much higher temperatures and lower humidity. So you start to really increase that drying from the bottom up. And one of the things that that I keep reflecting is that the Murray-Darling Basin, we don't notice it so much in terms of a drying landscape, because it was never a big permanent water body like the Aral Sea. But the amount of drying that's occurred in the lower parts of at least the northern basin is probably similar in a sense of a spectacular amount of moisture that gets lost. It's just not as spectacular as the Aral Sea. So people don't take much notice of it. So one of our biggest challenges in managing dryland river systems is how we actually accommodate agriculture, which is not going to go away, and it needs a more predictable supply of water with the natural variability of dryland rivers. And just because I'm sitting in Queensland, and because this is the River Basin Management Society, I have to sort of put a final note to, I'm not quite sure that damming northern rivers in Australia and then trying to pump water thousands of kilometres, apparently downstream because it's flowing from the north to the south, which is an argument in Queensland that's only just starting to, people are realising that it's not actually downhill from northern Queensland to southern Queensland, but we won't go there. It's not feasible, and it just dries out more river systems and basically hangs more water out to dry. So that's my, I guess, introduction and ramble on dryland rivers and some of the issues with water management. Thank you.